question 116, populating next right pointer to each node. Let's see what the question is giving us. The question is saying you are given a perfect binary tree. So a perfect binary tree is given to us where all the leaves are on the same level and every parent has two children. So this is the definition of a perfect binary tree. The binary tree has the following definition. So what is telling us, it's each node has a value. It has left pointer, right pointer, and next pointer. What is asking us? It's asking us populate each next pointer, which is this one, right? Each next pointer to point to its next right node, and if there is no next right node, the next pointer should point to null. And one more thing is given to us. It says initially, so by default, all the next pointer are set to null. So by default, every single node in the tree are pointing to null, right? So this is the perfect binary tree is given to us, and we need to make it like this. So we should set all the next pointer to point to the next right node, and if there is no next right node, it should point to null, which is by default it's point to null. So for this part we don't need to do anything. All we need to do is to make these pointers to point to the next right node. So let's see how we can do that. For doing this, we can consider two cases that we have here. One case is when the both nodes are the children of a same node. So the left node is pointing to the right node. They are both the children of a same node. But what if we have this case that this node is pointing to the other node, but they are children of different nodes? These are two cases that we need to handle. And for doing that, we are going to use two pointers. One pointer is pointing at the levels, and another pointer is pointing at the nodes in each level, right? At the nodes in each level. So we are going to have two pointers to solve this problem. So let's jump to the code. So here, as I mentioned, the next pointer is pointing to none by default. As you see here, all the nodes are pointing to none by default, right? So let me add this one here too. So let's copy and paste. All the nodes are pointing to none, as you see here, right? And what we are going to do, we are going to use two pointers. So we are going to use two pointers. One pointer, which is most left one, is pointing at levels, and the reason it's called most left because we start from the most left node, and that's all we care about for this pointer. We just need to traverse through each level, and the left pointer is going to point at every single node in the binary the perfect binary tree. So we are going to use two while loops. One while loop is for the level, like most left pointer for traversing the levels, and one while loop is for the pointer, the level pointer, which is for every single node in each level. So both pointers start from the root node, and the root node is by default is pointing to none. And what we are going to do when we are pointing at each node, we are going to check the next level nodes. So this is how we do it. So we start from root node, and we say if while level, when there is a node here, we are going to set level.left dot next, this one, to level.right, and this is the one case that we had, that both nodes are the children of a same node, and this is for handling cases that the children are not the children of the same node. So we are going to check if level.next, which is none here, exist. So this is what we are going to check. We are going to see if level.next exists, and if it doesn't, we don't need to go through this if. So we are going to set level to level.next, which is going to point to none, and it says while level, so this is none, so we don't need to do anything. And we are going to go through this while loop. So we are going to use the move the pointer to point to the most left node. So this is what is happening here. So this is the root node, and this is the left node, so it's going to point at this one. And then we are going to set the level pointer to point at the same node here. So let me move this here for clarity purpose. So here, and now what we're going to do is we're going to say if level, like while level, when there is a node here and it's not none, level dot left, this one, dot next is going to point to level dot right. This is the case that the both nodes are children of the same node. And for the second case, we are going to check if level dot next exists, and now we see level dot next exists is not pointing to none, so we need to check this condition, and if it exists, we are going to see if level dot right dot next, level dot right dot next is going to point to level dot next dot left. So for better understanding this, I'm going to change the color. So you see level dot right dot next is going to point to level dot next dot left. This is how it works for the connection between children of two different nodes. And after making that connection, we're going to move the level pointer to the next node, which is here, right? And then we are going to see if while level, so this is level, so it's not none, so level dot left, level dot left dot next is going to point to level dot right, right? And then we are going to check if level dot next exists, so it's none, so we are not going through this if condition. And then we are going to move the level to the next one, right? And it says, okay, if while level, which is none, so we don't need to go through this, so we are going to move the pointer from here to here, right? And then we are going to move this pointer to point to the same node as well. And now we are going to see if we are going to see if actually, like, we are not going to move this pointer is pointing to this one until we check this condition. It says while most dot left, is there any left here? So it's none, so we are not gonna go through this while loop at all, and we are done with this tree, and we have made all the pointers here to point to the next one, and if there is no next one, is pointing to none, and we are done with the traversing the whole tree. And the time complexity for this one is on, although we have two while loops, but one while loop is just iterating over the levels, and we traverse each node only once, so it's gonna be a linear time complexity, and the space complexity is constant because we are not using any extra space. Thank you.